Hey everybody, today we're going to talk about how we draw tape diagrams from equations and write equations from tape diagrams. So you'll need your math notebook out to take some notes. And remember, you can pause the video at any time you need to. So equations with tape diagrams. And this will eventually help us when we get into word problems, kind of sorting through the word problem and figuring out which information we need and where it belongs. So there are two different types of tape diagrams that we draw. We can draw them when we add and subtract. And that one, when we draw it, we just draw a box like this. It's easy on notebook paper, just have your lines. And the top is always the total. So that's the total or the largest amount in your problem. And then the bottom is split into the parts that make up the total. So you might only have two. There's a part and there's a part. When you multiply and divide, it's a little bit different. So you still have your total or your largest part. But remember, when I multiply and divide, it's groups of something. So I'm making equal groups of a certain number. So 3 groups of 10 or something like that. So we will end up, we can make those little groups in here if our numbers are small enough. But if they're not, we're going to end up with a box that is what each group is worth. So it just says each in it. It's just a little box that says each. And today we're going to use some really small numbers, so we'll be able to draw these out and draw our groups in here. But when we get into larger numbers, we're going to make that each box. All right, so here's an example. So write this in your notebook. So if I have an equation like 80, equals x plus 4. And I have to make a tape diagram for this. I first think about what my largest number is going to be. Well, I'm adding these together to get this number. So this is going to be my total or my largest number. And then I always just, even though some people like to make a smaller box for the smaller value or a larger box for the larger value, I just split it down the middle. And x will go in one box and 4 will go in another because I'm going to add those two together to get my 80. Now these models end up working really nicely to write different equations and to help you solve equations without having to do anything with an inverse. So what I typically do is I already have this equation written, but if I were asked to write a different equation, I could. So my equation says that 80 equals x plus 4, but from this diagram, I can also pull, and I usually use my total to start, 80 equals 4 plus x. I can also pull from this that 80 equals, or 80, excuse me, minus x equals 4. And I can also pull that 80 minus 4 equals x, since I know 80 is my total, my biggest number. So now I just have to figure out what my value is for x. We've done this before. It even sets one of the equations up really nicely for you to figure out what 80 minus 4 is. So in this case, x equals 76. Let's do another example. So this one's going to be a subtraction example. 300 minus 40 equals x. And again, I set up my tape diagram. So I know that if I have 300 minus 40 equals x, this number is going to be smaller than this number. So this is going to be my total, my largest number that I'm working with. And then my other ones, since it's subtraction, are going to be my parts. It doesn't really matter which one goes in which box. I could flip these two and have the x in the first box and the 40 in the second box. It doesn't make any difference. So they gave me the original equation to start here. So now I look at this and see what else I can pull from it. Well, this equation was 300 minus 40 equals x. I could also do 300 minus x equals 40. And since addition is the inverse, I can pull that from this as well. So I know that 300 is equal to 40 plus x. And 300 is also equal to x plus 40. Now, the first equation they actually gave me is the easiest one to pull the answer from. So 300 minus 40, x would equal 260 for that one. All right. Now let's try a multiplication problem. So 4 times z, and remember you might see 4z equals 8. This one's a little different because it's multiplication. I have small enough numbers that I don't need my each box yet. So remember, I'm thinking about the groups I have. So I have something times z equals 8. Well, I know 8 is going to be my big number. That's my total. So now I'm looking for 4 groups of z or z groups of 4. Well, it's going to be hard to draw z groups, right? Because I don't know how many I need down here to make my total. But I can easily draw 4 groups of z. So I'm just going to split my box here into 4 parts. And then each part becomes z. And so now I can write my equations based off this model I have. So they gave me 4 times z equals 8, or 4z equals 8. I could also say z times 4 equals 8. Well, if we think back to the subtraction one we just did, we also found the inverse. We did addition as well. Do you think we can pull we can pull division from this? We can actually pull some division problems from this. So I could do 8 divided by z equals 4. Or, which is also looks like this, I could also write this way. 8 divided by z equals 4. Or, because 8's my total, it has to stay here. So I could do 8 divided by 4 equals z, which would look like 8 over 4 equals z. I can't have my 4 here because I need my total in front here when I divide. It's just like subtraction. I need the biggest number in the front, the largest number. So then I just solve for z. Well, if I look at this, I already have one that's set up really nicely here for me, right? So 8 divided by 4. So 8 divided by 4 then is 2. So z equals 2. Division works pretty much the same way. Again, I'm using small numbers, so I don't have to draw my each box. So I have 32 equals b divided by 8. So if I wanted to, I could also write this, remember, as b divided by 8 equals 32. So what is my total? What's my largest number going to be in this problem? Yeah, it's going to be my b here, right? My b is going to be my largest number. So that's my total. I don't know my total. That's what I'm looking for. So now I can either do 8 groups of 32 or 32 groups of 8. Well, this is where things get a little bit tricky. I can still fit 8 boxes down here. I could also use my each, which means that in each group, there are so many. I can draw 8 boxes though, so we're gonna fit 8 in here. So that's 4. And each one of those boxes is 32. So this is where I would do my, if I was doing an each, if I didn't want to write it in each box, and then I know how many boxes I have here, I could also write it in all of the boxes. Either way is fine. So then I can write my equations. So they've given us the 1. We have b divided by 8 equals 32. I could also do b, since that's my total, divided by 32 equals 8. And remember, those can also be written as fractions, so it could be like this. Could I write it as a multiplication problem? I could, right? I can write this as multiplication. That would be 32 times 8 equals b, or 8 times 32 equals b. I could even write it as an addition problem if I wanted to. I could do 32 plus 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 32 equals b if I really wanted to. I could also get that addition from there too. And so then you just have to solve for what b is. Well, this equation sets it up nice for us all on one side, so I don't have to move anything. So just to figure out what 8 times 32 is, and if I figure out 8 times 32, I should get 256. All right, so now I'm going to give you some tape diagrams, and I'm going to have you write the equations for these tape diagrams. So I'm going to draw these on here. So draw these with me. So draw those two, pause the video, and I want you to see what equations you can write for each of these. Try to write 4 for each one. All right, so let's look at what you did. So one of the equations I could have had 132 equals 75 plus x. And you could have this written as 75 plus x equals 132. You could have them reversed. That's fine too. I could also have had 132 equals x plus 75. I could have had, then if I do subtraction, 132 minus 75 equals x. And 132 minus x equals 75. So all of those equations would have worked out perfectly. And then if you didn't solve for x, pause the video and solve for x. And x should have been 57. For this one, I have groups of the same thing here, so I know I'm multiplying or dividing. So this one, 48, and I have 1, 2, 3, 4, 5, 6 groups of C, or I could have written this as 48 equals 6C. I could also have this as 48 equals C times 6. I could have 48 divided by C equals 6, which would also look like this. And I also remember I need that total needs to be in front for division problems. Divided by 6 equals C. Well, this one is probably the easiest to solve from. So C should equal 8, which means each one of these stands for 8. So I could have done C plus C plus C plus C plus C plus C, too, equals 48. Now I'm going to give you an equation, and I want you to draw the models for that equation. So make your boxes. So your first equation is C equals 20 plus 40. So pause the video and work that one out. Draw your model. And solve for C. So C should be my total up at the top. And then my boxes would be 20 and 40. And this one is pretty straightforward because we have all of our adding on one side. So C would equal 60. Now let's try this one. 9D equals 54. Pause the video and draw your model and find what D is equal to. So I know this is equal to 9 times D equals 54. So I have to figure out first what my total is. Well, that's my 54. And because I'm multiplying, remember, it's groups of. So this is 9 groups of D, or D groups of 9, but the D groups doesn't help me divide my groups. So I would have 9 total groups here. I'm going to draw my each box here. You didn't have to. You could have drawn your 9. So this would be 9 groups, and each one is D. You could have also drawn it like this, would have been completely fine too. You just would have had to make a big, you could have done 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, like that too. And you could have done this. And then you solve for D. So how much is each one of these? Well, D should be equal to 6. And so that is how you write equations from tape diagrams and draw tape diagrams from equations.